Bhargav. I am working as a trainee software engineer at Aja Consulting Services. Today I am going to explain about expense tracker application backend. This is an expense tracker backend developed using fast APIs and PostgreSQL. This application allows users to track and manage their expenses, categories, and incomes and budgets. This is the project folder structure. This is the main file. uh, this is where our application connects with the fast API server, and here I have imported the fast API and routers from routers folders. And here, instead of writing all the routers in one file, i I have imported it from other files, like creating a router folder in for each model. I have write routers separately, and this is dependencies for authentication dependencies. Mm, this will make sure that only uh, logged in users can access these APIs. And the second folder is database folder. Here this is database URL. Here I have given credentials like password, uh, database username, and database name. And using this database URL, I have created engine which will help us to connect with database. And this is a session which is used to retrieve or store data into the database. And we will be importing this get underscore session into other folders. This is a schema folder. uh, Here I have written schemas for each and every model. These schemas are used for request response models. uh, for example, if we take users, in this field we have email, name, and password. When a user passes the data, name will check it the schema will check uh, whether name field is there or not, and if it is there, it will check if it is string or not. Like that, email for email also it will check it if whether the email is in proper format or not. And this is hashed password. It after it takes the while signing up, uh, the application takes the password which user passed, and hashes the password, and it stores in this hashed password. And here we can also provide customized validations for the fields using field validators. Here I have passed a field validator for name column. uh, Here in this method takes the name and strips the ends of the name with whether there are space or anything. And this step replaces space with nothing if there are any spaces in the middle of the name, and checks if everything is a alphabet or not. if uh, if it's not true, it raises value error and shows the output name should be an alpha. And if it's not true, if it's true, uh, it will return name. Like that I have also wrote schemas for every model. I have wrote for update update model and create model. Update model is for updating data in the table, and create model is for creating the data in the table. And this is a response model. It shows in the swagger. The next folder is rotors. I have wrote rotors for in different files for each model. These are as authentication models. Here I have imported schema, necessary schemas and get session and models. This is a sign up router. Here it will take request from user. Mhm. And creates the user in the table. This is sign in. Here it will take the data from the user like email and password, and uh, this verify user verifies whether the password is correct or not. If there are no users, it will raise user not found error, and if there is a verified user, it will give token. It will generate token and gives the token. If uh, the email or password is not correct, it will raise error like incorrect password. This is authorization router. Here I have, for each model I have created 5 APIs. For example, for user router I have created 2 get APIs. This get API is used for getting all the users in the user model, and this get API is used for getting user by using user ID. It is used for getting finding single users, and this put API is used for updating user data, and this delete API is used to delete the data. Like that I have created for every model. All I have created 5 APIs. All APIs are REST APIs. This is a post API for expense model. It is used to create expense in the table, and this is put API. It is used to update the expense, and this is delete API. It is used to delete the expense. And these are models. Here I have imported all the necessary update models and scheme from schemas. This is user model. uh, uh, this user model contains name, user ID and email and password. This here hashed password will be stored after it is hashed. And I have also built relationships for category, expense, income and budget, because a single user can have so many categories, expenses and incomes and budgets. Like that I have created models for category also. Uh, Here user stores the category of the uh, a category like food, rental, etc. In this, there are fields like ID, name, user ID, user, category expenses, and category budgets. And this file is used to log every API request. It records request information for debugging and monitoring. It helps developers identify errors and monitor API usage. Whenever a user sends a request, it first comes to fast API through main.py. The request is then forwarded to appropriate router. The schema will validates the input data. Authentication checks the JWT token. Business logic process the request. The database session stores or retrieves data from the PostgreSQL, and finally the response is sent back to the client. And in fast API we also get Swagger UA. If we run this is Swagger UA. Here we can see what REST APIs we are running on our local host. This is auth. This in auth we have two APIs, sign up and sign in, and this is users. In users we have four API. uh, in user we don't have post API because this sign up is the post API for users, and these are get APIs and one post API and delete API. Income also have 5 APIs, and every model has 5 APIs. This is inbuilt Swagger for fast API. This project follows a modular architecture. Each module has separate responsibilities, like main.py starts the application, and database.py it manages the database connection, and models.py here models.py defines database tables, and the schema folder has all the schemas, and it validates the data, and the routers folder contains the API endpoints. This structure makes the project clean, scalable, and easy to maintain. And this is my project. Thank you.